to this video on Excel graphing and shortcuts. So in this lesson we're going to look at some of the basic shortcuts that you can use in Excel, and a lot of these are very similar to most of the Microsoft Office programs. We're going to look at entering data, making graphs, adding labels, trend lines and R-squared values, calculations and functions, and extending the trend line through the origin. So it'll start off quite basic, and as we go through I'll add more and more features and get more and more advanced. So if at any point you feel like you already know this, feel free to skip ahead, or if it gets to a point where it's too complex or beyond what you're expected to do at this year level, feel free to just stop at that point. So let's get into it. So I've got my Excel spreadsheet up, and I've already entered just some basic values here for time and temperature, and that's what I'm going to measure. So the first little trick or shortcut that is handy is that if you double click a column adjuster, it automatically spaces to your largest value. So in something like this, sure, it's easy just to drag it to whatever I want, but in some examples where you can have lots and lots of data and you don't really know how big or how small you can make it, double clicking just makes it the smallest possible format that you can. So firstly, I'm going to enter some time, and if I'm going to go just from 0 and I'll increase every second, which is pretty extreme, but I'm going to measure every second. The next little trick is that Excel can sort of automatically figure out what you're trying to do and fill the rest of the values. So here I've written 0, 1, 2. If I highlight this and then drag the little corner where it becomes a black cross, if I drag that down to 20, you can see it already picks up the pattern. It says, oh, you're counting in ones. Let me do that for you. Here's all your values. So this is time. I should certainly measure the units so I know what I'm measuring. It's seconds. It's not hours or days or anything like that. And same for temperature. I'll say degrees Celsius. And once again, I can double click if I want to. So now I'm ready to enter my data. So in this case, this is an experiment that I'm adding data to. So I would measure it and I would get values that look like this. If I make a mistake, such as this, and I want to undo that, the shortcut for that is just Control-Z, and it takes me back to the previous step that I was at. Another neat little trick is if you had a lot of data and you want to select an entire row or column, you can use the Control-Shift arrows. And if I press Control-Shift down when I'm selecting at the top, it'll highlight all of the values in that column up to my last data point. So it doesn't highlight the entire column, it just highlights my data. So Control-Shift down, and if I press it again, now it gives me the entire column to basically infinite numbers. So that's one trick. I can do the same thing if I want to select a row. So I can press Control, Shift and the right arrow, and it'll highlight all the data in that row. And then again, if I press it one more time, it selects every horizontal cell in that row. So again, if you've got lots of data, that can be quite useful. For basic graphing stuff like this, it's easier just to kind of drag things. I can also hold Shift and use my arrows if I want to select things. So by holding Shift and then just panning around the place, I can select certain data points. Now let's get on to making a graph. There's two main ways that you can do this. Often you can just highlight the values and then just go Insert and then Graphs, and that's, in most cases, that works pretty well. Another way you can do it is you don't even have to have your graph data selected. So I can still build a graph with no initial data. And the process is very similar. So we'll start there. If I insert a graph, and in physics and in a lot of science, most of the time we're using a scatter plot. So you can have a scatter plot with lines and things like that, but most of the time those lines are completely useless. They're not actually telling us anything. So the graph that we really want most of the time is this scatter plot here with no connecting lines. So I'll select that, and here's my beautiful graph. The problem is I've got no data, so I want to add some data. So if I right click the graph and I go select the data, now it pops up with my little thing here. It says, all right, tell me where you want your data to come from. So I just go add some data. And now the series name is what I'm actually graphing. So if I'm only graphing one thing, in this case it's just temperature versus time, the series name can just be temperature versus time. It's only if I was plotting multiple things. So if I had like temperature of water versus time, temperature of oil versus time, jelly versus time, whatever, and I want to put them all on the same graph, then I would name them different things. And that's what it means by a series. The series is what is your data. But for most of the time, we're only ever going to have one series, so it's pretty straightforward. Now it's saying, what is the X values for your series? And so I just click that and I drag over all of my time intervals, and you see it's automatically adjusted to try and fit that in. Now I go, what are my Y values? And I need to delete this little thing because whatever this is, it's completely useless to us and it'll mess up our data. So now I say, these are all my Y values. This is what I measured, or we might call this our depend variable. I'm going to put that in, and again, you can see it's now configured the graph to fit my data quite well. So I'll say OK, and you can see it's already given me a heading, temperature versus time, which was the series name, and I click OK again, and we've got a very basic graph. So now there's a few main features that we need to look at, and when we do a graph, there are some very important aspects that we must include. Almost all of these things I can find by clicking this little plus symbol. So I add elements. First thing I want to do is axis titles, and now you can see I've got those. I could add data labels. It depends on what your data is and what you're doing, but often you don't need these. In this case, you can see if I have data labels, it makes it very sort of congested, and there's a lot of information here, but some cases it may be useful, and I can go through and delete individual data labels if I wanted to, just to show a certain point. Error bars, again, that's quite advanced. You probably wouldn't be expected to use error bars most of the time unless you're doing some very complex or high-end analysis of your uncertainty within the measurements. Grid lines, always. The legend, if you want to. Again, that's more if you had multiple pieces of data. In this case, I only have one, so it's not necessary. And now my trend line. So the trend line, it's really worth clicking this little arrow and going to more options, because not only can I use this to actually get my R² value down here and also my equation, but I can use this for a bunch of other things. And the trendline types are just saying, let's try and fit some sort of a line to your data. In this case, it's a linear line, so a straight line, but you may encounter an example where you expect it to be a quadratic, so a polynomial, or it could be exponential, like when we do radioactive decay and things like that. I might say, let's try and fit an exponential graph to my line. Otherwise, in this case, it's clearly linear, so I'm going to stick with that. If you're ever in doubt of which trend line to use, there's a bit of a trick. If I look at my R² value, the idea is that I want that to be as close to 1 as possible. Generally, when you're doing an experiment, the closest you'll get is 0.99 something. It's very rare to get a perfect 1. To get perfect 1 means every single data point lies exactly on that line. But if I'm trying to figure out what the best trend line is, I can just try a few different ones and say, well, this is 0.986. The trend line for this one would be 0.985, so it's worse. So I could try my linear line, and I can see that that's a 0.986 R² value. And I could try other versions, and I could say, well, is it exponential? And that's 0.985, so it's slightly worse, but not by much. So in some cases, you just need to think about the logical aspect of what makes more sense. If I choose exponential, that's suggesting for this experiment, the temperature is going to start just massively increasing very soon. So it's going to start slow and then speed up. And we don't really expect it to do that realistically. So I would expect it to be more consistent, that if I'm just heating it the same amount, the time should just increase by the same amount. So now I've got my equation of my line, and I've got my R² value. I can just click or double click my axis titles and use my Control A shortcut to highlight, or if you aren't confident with that, you can just drag over it. And then I label it. And in this case, I have time. Remember, it must have units. And this axis is my temperature. And now I've got my axis labels. So I've got my main heading, my axis labels, my data points, my trend line, my R-squared value, my equation of the line. Obviously, you can do a lot of formatting with this. So there are different options up in the chart design. I can switch it to sort of a high contrast version, which is completely fine. And there's a whole range of other things. And I can change colors for different things if I want to. You can change all my data point colors, and you can really play around with that and get pretty crazy with it. So the next thing is that if my data didn't pass through 0, so if I just delete these two values for a second, you can now see that in terms of my trend line, it's not actually passing through the 0, 0 point, or it's not even going back to pass through anything. So I have no idea what value it would actually have back at time 0 if I wanted to calculate that theoretically. And in physics and higher level science, that's very, very important. We want to know what that is because that tells us if we have a systematic error. So there is a way that you can force the trend line to go backwards. And that's this thing down here. So this forecast forward and backwards. So we can just put in a value here. So I want it to go backwards a little bit. So I'll come down here and I'll have a stab at 1 step backwards. And then as soon as I click out of the box, it'll do its thing. And you can see that was enough. So in this case, 1 jump backwards was enough to get it from the data point 2 to 1. So that makes sense. Sometimes you may need to go more, or I may want to know what happens, how far back does this graph have to go before it crosses the x-intercept. So I might just make up a number here, and I'll say 10, and now I know way back here on the 0, 0 line, it crossed somewhere around here, maybe around the -3 as the x-intercept, if that was useful. Most of the time, we only ever want to know this point, because if this is not 0, 0, then that tells me either some useful information, or it tells me that I've got an error. Excellent. So that's the basics of graphing. You've got all your things here. Most of the time, you just do it through this little plus. If you need extra features, you can choose which one you turn on, which one you turn off. Same with axis labels. I can change the widths, the sizes, all sorts of jazz. Trend lines are down here, and I want more options, and that's how I end up with my trend line things, where it tells me which trend lines do I want. Forward and backwards shifts this trend line or extends this trend line as far as I want it to go. I can force it to go through the 0, 0 origin if I wanted to. It's not often useful because that's not really experimental result. That's kind of just forcing the result to do what you want it to. I click this to display the equation. I click this to display the R-squared value. And that is graphing.
Bye, have a beautiful time.